Guys, remember this question? So last night I tried to solve it and yes, I succeeded. So I don't remember the whole process of what I did, but still I'm going to try it once again to see if we can actually solve this or not. Okay, so I think we did something like this, that the limit as n approaches infinity of this thing, that would be the same thing as the limit as n minus 1 approaches infinity of 1 power 99 plus 2 power 99 all the way till n minus 1 to the power of 99. Okay, so why is that? Because the difference between these two numbers, this thing and that thing, that is very small, right? And we can prove that over here. So 1 power 99, actually I should do this thing. 1 power 99 plus 2 power 99 all the way till n minus 1 to the power of 99 upon n minus 1 to the power of 100 minus 1 power 99 plus 2 power 99 all the way till n power 99 upon n power 100. This thing can be written as 1 power 99 all the way till n minus 1 to the power of 99 into 1 upon n minus 1 power 100 minus 1 upon n power 100, right, and minus 1 upon n. So this thing is going to be 1 power 99 to n minus 1 power 99 upon n minus 1 to the power of 100. Okay, and over here you will have n power 100 minus n minus 1 power 100 upon n power 100, which is much better written like this: 1 minus n minus 1 power 100 upon n power 100, right? So this is much better, and minus 1 upon n. So this thing, this complete quantity is a finite quantity, right? Because you have 1 upon n minus 1 as the last number, and the first number is also very small. So like this is almost like a lot of small numbers added together, yeah, something like that. And yes, this is going to be something like a finite quantity, right? And that's why we are supposed to find the limit, right? Because this is going to be something which is finite. And this thing, 1 minus n minus 1 power 100 upon n power 100 minus 1 upon n, actually this is not like this. Okay, so bracket should be over here, right? So this thing approaches 1 as n goes to infinity. So this complete thing approaches 0, and this thing is a finite quantity. So 0 times a finite quantity is 0, and minus 1 upon n, that thing also approaches 0. So that means that the difference between these two numbers is going to be very, very small, right? So actually it's going to approach 0. So instead of saying very, very small, we can say that that is non-existent, right? There is no difference. In fact, these both things are the same. Okay, that's nice. So now we can use the theorem on equal ratios for these things. So this is also going to be equal to the limit as, maybe just say n approaches infinity. N approaches infinity of, so subtract the numerators. So this is going to be n power 99, right? After subtracting the numerators, you get this thing. Subtract the denominators, so n power 100 minus n minus 1 power 100. Okay, and now you just need to find what this limit is. So this is going to be the limit as n approaches infinity of, so 1 upon n minus 1 into n minus 1 upon n to the power of 99, right? Which is 1 upon, let's see, n into 1 minus 1 upon n to the power of 99. Yes, and you also have plus, I think, yeah, so plus n minus, okay, so plus 1 minus, okay, that looks better. And then we can just use um, the general binomial theorem on this thing, right? In fact, let's just use the general binomial theorem on that thing itself. So just say this thing is like 1 minus 1 upon n, right? So 1 minus 1 upon n to the power of 99, this is going to be 1 minus 99 upon n plus some other stuff which has 1 upon n squared into that thing. So this is going to be 1 upon n minus, so multiply this thing by n, you should get n minus, oh it's plus because minus n, right? So minus n plus 99 minus 1 upon n times some other stuff, and multiply this thing by minus 1 and then once again minus, so it should be plus. So it's going to be plus 1 minus 99 upon n plus 1 upon n squared into some other stuff. So this is just 1 upon this cancels, so 1 upon 100 minus 1 upon n, actually plus 1 upon n times some other stuff, right? And as n approaches infinity, this thing just goes to 0. So this thing is going to be 1 upon 100. Now this is a very, let's just say, non-conventional method, because I don't know if theorem on equal ratios is like really valid over here. I think it is, because that's how we did the proof of that L'Hopital's rule for the infinity upon infinity case, right? So say you have something like f of x upon g of x, right? And here x is approaching infinity, so this thing would be the same thing as f of x plus dx upon g of x plus dx, and then we had to use the theorem on equal ratios to say this is also f of x plus dx minus f of x upon g of x plus dx minus g of x, and then from there this is obvious that this is going to be d f of x upon dg of x, d f of x dg of x. Yeah, so that's how we proved the L'Hopital's rule for the infinity by infinity case. I mean, it's not exactly a proof, but it gives you a general intuition of what should be happening. And for the 0 by 0 case, I think we did like the inverse first and then take the derivative. I don't know. So that's how we do this question. And in fact, for any general value, say you have 1 power m plus 2 power m all the way till n power m upon n power m plus 1, this thing is just going to be 1 upon m plus 1, right? So you can try it out, take some small values of m, say 1 2 3, and try it out. You are going to get this thing every time, right? And this is like limit as n approaches infinity. So that's it. I will see you in the next video.